Hi, everyone. Welcome back to RightStart Math Online Conference 2025. My name is Teresa Fulton. I have just a little bit about myself. I have 5 children, all of whom have used RightStart. We didn't start off with RightStart. I didn't know about it in the beginning, but thankfully we found it pretty early on, and it made a world of difference for all of my kids. So I'm really excited to be here talking to you about Dr. Cotter's new book. This is Start Math Right, and I have the division chapter. So we're going to be talking about division today. We will have a Q&A session at the end where both Dr. Cotter and I will be happy to answer your questions. So go ahead, and if you have questions that pop into your head and you want to put them into the chat, that's perfectly fine. Or if you just want to save them and ask us at the end, that's okay too. All righty. So of all the arithmetic operations, so addition, subtraction, multiplication, and division, division is the most complicated. With longer division, you're really required to use not only division, but multiplication and subtraction. And interestingly, there are several ways to write a division problem. So the first one here, 32 divided by 8, we're using a division house, and we'll talk about that a little bit later. The next one is the division sign, and then 2 different ways to write fractions, right? Which of course are also division. Did you know that division has 2 different perspectives? Lots of times people don't even think about this, but one is finding the size of a group, and the other is finding the number of groups. So here is an example of the first one, 7 groups of 4. Okay, I'm using a part whole circle to illustrate that there are 7 groups. There's 7 little circles, and there's 4 in each of those groups. This next one is just an example of 4 groups of 7, right? So just the flip-flop of that. Now, a better way to visualize division is by using the Cotter abacus. Using the same example, 28 divided by 7, we will first place 28 on the abacus, just like we have here. And then we're going to start moving beads down to the 7th wire, because we know that we have 7 groups. Choosing 3 beads to move, in my case, it's just a trial and error kind of thing. It's not that 3 is the magic number. I could have chosen 2, I could have chosen 5. I'm just choosing 3 for demonstration purposes. So we're going to continue to trade those 3 beads from the upper wires, from the 28, and put them down on the lower wires. Now, at this point, it's really obvious that there's more beads higher up on those wires compared to the lower ones. So we're going to just have to even that out. So I'm taking 3 from the first 3 wires, 1 each, and placing 3, 1 each on the lower 3 wires. So now we've evened it out. We have 4 beads on each of those 7 wires, and that shows that 28 divided up into 7 groups equals 4. So in this one, this is just another perspective. We'll find out how many groups are needed if we want 7 in each group. So we're going to start off with 28, just like we did before. And I'm going to remove enough beads on those wires to leave 7 on each of those first 3 wires, right? So that group that I've moved to the side, I'm just moving it slightly to the side to set it apart so you can see that there's 7 on the first 3 wires. And now I'm going to deal with those extra beads. So I'm going to trade from the 3rd wire 1 bead. I'll remove 1 bead and I'll put it on to the 4th wire. Okay. We're using the take and give strategy to move those extra beads, all of them, to the 4th wire. So now on the 2nd wire, I'm removing 3 beads and I'm putting 3 beads back on to the 4th wire. And I'm doing the same with the 1st wire. Removing 3 beads, putting 3 beads back on. All right, so now we have 4 groups of 7, right? It's still 28 divided by 7 or 28 divided by 4, whichever way you want to think about it. Another really nice way to demonstrate division is using the math balance. So obviously in real life, you would be using a balance that can get unbalanced, right? So that you can see what's happening. You know, this is a static balance. We can't really make it unbalanced, but you'll get the point. Okay, so using the same equation, 28 divided by 7, I'm going to place 2 weights on the 10, that's the 20, and 1 weight on the 8. So 28 on the left side. And since we're dividing by 7, I want to put weights one at a time on the 7 to make the balance, right? So if you do that one at a time, it will balance once you've put the 4th weight on. It's really cool in real life. In this second example, I still have 28 on the left, but now I'm trying to figure out how many weights need to go on the 4 in order to make it balance. And sure enough, you need 7. But the super cool thing about doing division on the math balance is that you can do remainders too. So here we've changed up the problem just slightly so that we have a remainder, obviously. We have 29 on the left side, and we have 4 weights on the 7. That isn't a surprise to us. But there's a single weight on the 1. That represents the remainder, right? So when 29 is divided by 7, the answer is 4, remainder 1. Now let's look at the other problem. We can hang 7 weights on the 4, and we still have a remainder of 1, right? So that's just illustrating the 2 different perspectives of division. All right, so the next thing we're going to talk about is story problems and solving real life problems, okay? So how to handle division, a division remainder is really most important when you're trying to solve real life problems, right? So the following 5 problems that I'm going to share with you highlight the importance of deciding what do I do with that remainder. So let's look at problem number 1. Here we have 13 children. They're going on a field trip. If 4 kids can ride in a car, how many cars are needed? So I'm going to let you think about that for a second. Someone who's only concerned with school math, but not with really solving the problem, may say that the answer is 3 1/4. But that kind of brings up a problem. What do you do with that extra person? It's not like you can divide them up into fourths, right? So the real answer is 4, because you need to put that extra person somewhere, right? You can't leave them behind. You can't chop them up. So you've got to have 4 cars, right? Now, that might result with people not sticking to 4 children in a car, which is fine, but you still need that extra car for that leftover person, that 1 extra person. Okay, let's look at problem number 2. Pauline has 13 petunias to plant, and she wants exactly 4 in a row. How many rows can she plant? Well, now what to do with that extra petunia? You're open. There's a lot more acceptable options on what to do with that one, but the answer is still not 3 1/4, right? The answer is 3 rows. She can only plant 3 rows because she wants 4 in each row. Now, she could throw away that extra petunia. She could sell it. She could plant it somewhere else. She could give it to a friend, right? Those are really acceptable answers on what to do with that extra petunia. But the answer is 3 rows. All right, problem number 3. 4 children have split $13, right? They have $13 to split amongst themselves. How much does each one receive? So after giving $3 to each child, there is $1 left over. What can we do with that? Well, we can split the dollar into fourths, and every child receives an extra 25 cents. So each child will get $3.25. All right, problem number 4. 4 children divide 13 candy bars. How much does each one receive? Now, if the money problem wasn't motivating enough for the child, this candy problem is probably pretty motivating. They are going to be really keen to know how much of the candy bar they get. And soon they will realize that they get 3 1/4 candy bars. All right, one last problem. Problem number 5. Jack packages 13 cookies with 4 per bag and eats the leftovers. How many does he get to eat? Now, if you're reading it carefully, you will see that the answer is going to be very different from all the other problems that we've worked on, right? Because the answer is 1. He gets to eat 1 cookie. Now, it's really interesting to note that all 5 of these problems dealt with the same numbers, right? They all dealt with 13 and 4, but they all have different answers. 4 cars, 3 rows, $3.25, 3 1/4 candy bars, and 1 cookie. This is the real world where context really makes a huge difference, right? To solve these problems, students must visualize the scenario and then check their answers to make sure that they make sense. So a child who's just rotely answering the problem without really thinking about the problem would end up with 3 1/4 probably every single time. Maybe not for the last one. Maybe if they read it carefully, they would not end up with that. But it really takes, they have to slow down. They have to use logic to really answer the problem properly. Now, one thing that's really important to understand is that it's not just good enough to, memorize your math facts or memorize the algorithm, the procedure. What's really important in math is to be able to use math as a tool to solve problems, real problems, right? So just because a child can answer 100 questions, arithmetic questions, and get 100% doesn't necessarily mean that they really understand what they're doing. Because in fact, that child could, when faced with a problem that they've never seen before, have absolutely no clue how to use what they know in math, right? Because they don't understand what they're doing. So this is just, these 5 problems illustrate how important it is to really understand what you're doing so that you can use math as a tool to solve real problems. Okay. Before exploring short division, I just want to cover the ins and outs, no pun intended, of the division house, okay? There really isn't a definite term for this symbol that we're using, but we're going to use the term division house. Dr. Cotter uses that in her new book as well, and in the curriculum. All right, so to the left of the division house, we're going to put the divisor. So that's what we're dividing by, right? And then inside the house, we put the dividend. That is, so the divisor goes into the dividend how many times, right? And then the quotient goes on top of that bar. The quotient is the answer. And then if there is a remainder, we put that to the right of the quotient. So it's important to know the terminology and where everything goes, right? Okay. So now let's look at using the second side of the abacus to help us with learning how to do short division. This is a great way to introduce short division, and it's so much, short division is so much easier to understand than long division. Interestingly, up to just a few decades ago, short division was actually considered the gateway to understanding long division. But it was lost along the way. Most of us were not taught short division, And we just had to dive right into long division, which can be very difficult for children who are dealing with learning disabilities. In fact, it's probably really not the hill that I would choose to die on if I was dealing with a child who had learning struggles. Okay. So first, in order to use this for division, we're going to move the beads up so you can see that they're not sitting on the bottom bar. They're moved up part way. That's important. And the problem that we're going to deal with is 474 divided by 3. So notice that I've entered the beads that represent that number 474, right? So if you watched Rachel's program yesterday, she talked about how to use the second side of the abacus with addition. And she pointed out that each of the beads is worth the number that's above it, right? So look at those 4 beads that are entered under 100. That just means that each of those beads is worth 100. Then under the 10, each of those 7 beads is worth 10. So we have 70 or 710. And then under the 1, each of those beads is worth 1. So we have 4. All right. Excuse me. So we're going to look at what 400 divided by 3 is. So the 3 that was under the 100, because 3 goes into 3 one time, right? We're going to remove those 300s and place a 100 bead, move that down to the bottom. So 3 went into 400 one time. Our answer is going to end up at the bottom. Okay. And the 1 bead that's left over, the 1 blue bead that's left over in the hundreds place, that's the remainder of 100. And notice that I write a 1 above the 400, right? The 4 in the hundreds position. And then a little 1 next to the 7. That represents that remainder of 100, that blue bead that I left behind at the top. Okay. So now I'm looking at 1700s or 170, depending on how you want to look at it. And I want to know how many times 3 goes into 17, right? The 1700. 3 goes into 17 5 times, which would give me 15, right? So I remove the 15, so the 100 bead and the 5, so that's really 150 or 15 tens. I'm putting that back to the center and I'm pulling down 5 tens because that's how many times 3 goes into 1700. Or sorry, not 1700, 17 tens. I write the 5 above the 7 and I notice that I have 2 yellow beads in the tens column left over. That's my remainder, right? So now I write the 2 representing the 210 next to the 4. Okay, now I have, you can see I'm moving those beads, the 210 4 from the top. I'm asking myself, how many times does 3 go into 24? It goes in 8 times. So I pull those 2 10s and 4 1s down and I enter 8 blue beads at the bottom. And I can see my complete answer with no beads moving around. That's 158 at the bottom of the abacus, or 105 8. So the math way of naming numbers, when I'm saying the tens, instead of saying 58, I'm saying 5 10 8. That was covered a little bit in previous workshops. It's really important for kids to use that so that they solidify their understanding of place value. Okay, so that was covered in the number sense talk. All right, so let's take a look at short division without using the abacus. So they've already used the abacus to understand the process. And now we're going to move away from the abacus and do short division. We could still do this on the abacus, but there does come a time when the kids are doing it without the manipulative. They can look at it, but I wouldn't have them touch it. All right. So the first thing I'm going to do, and I could have done this back on the other problem as well, is put little dash marks above the dividend, so above the line, to represent where to write the quotient. Okay, that just helps the kids have a target for where to put the answer. All right, so the first question I'm going to do, the first step, is I'm going to look at the 8,000 and say, okay, how many times does 9 go into 8? Well, it doesn't. So how many times does 9 go into 80? It goes in 8 times, and I'll write the 8 above that 0 in the hundreds spot. Now, since 8 times 9 is 72, there is a remainder of 8. Right? So 80 minus 72 is 8, and I'm going to write that little 8 next to the 5. Now I'm asking myself, how many times does 9 go into 85? Well, it goes in 9 times because 9 times 9 is 81, right? So I'm going to write the 9 above the 5 in the tens column. And I'm going to write a little 4 next to the 3 because since 9 times 9 is 81, if you subtract that from 85, you get 4, right? All right. So now I'm looking at 43. 9 goes into 43 4 times with a remainder of 7, right? So since 4 times 9 is 36, I figure out the difference between 43 and 36, and that's 7. And I write the 4 in the ones column and the remainder of 7 off to the side there. All right. So there is, this was really hard to narrow down the entire chapter of the division. So I just hit the highlights. I really would love to have taken you through so much more, but I encourage you to get the book and read it because it is chock full. Every chapter is so much more full than what any of us were able to really deliver. Okay. These are the highlights, and I think that that will whet your appetite for, learning more about division and also just the best ways to teach math. All righty. So are there any questions? You're welcome to unmute yourselves and ask questions or put your questions in the chat. So go for it if you have any questions. Dr. Cotter and I are happy to answer. Kathleen, do we have any in the chat?
We do not currently.
Okay.
One thing I did put in the chat, I don't know if everyone saw it or not. The book that Teresa mentioned, turn my video on here. The book that Teresa mentioned, Start Math Right, will be, I'll kind of watch for the book release. It's currently in being published right now. So as soon as it is available for sale, we'll certainly let you know. So we are super excited.
Yeah, it's a great book. It's really very interesting. Okay. Well, if nobody has any questions,
So how is the book different?
Oh, yeah.
I just had a question. How's the book that's being released? How is that different from the RightStart program itself?
Right.
Which one should you do then?
Right. So the book is more of comprehensive look at how math should be taught, so that we can really make a difference in math education for students. So I would recommend it for people who, one, are interested in math and how it's taught and how we would suggest it be done differently than it is being done currently. And for teachers, it's a great book for teachers to just get a good background, because oftentimes in a school setting, a teacher is only teaching one grade, right? So it only covers one set of topics, and they don't really get to see what came before and what's coming after. So this kind of gives you a broader view of, what all needs to be taught in a sense. And so I would consider it really essential for teachers and administrators. For the homeschooling parent or for the parent who is supplementing what's going on in the classroom, I think it's an interesting overview of how it should be done. For the nitty gritty on how to teach particular topics, what lessons to do in what order so that you're not missing out on stuff, so that there's not gaps and whatnot, I would go with the curriculum for sure.
Yeah.
It'll be easier for you to implement so that you don't have to go, okay, well, that's a great idea. And how does that come to fruition down here when I'm working with my kids?
Yeah, the book does not have any lessons in it.
Right.
Does not tell
Okay,
you
thank
exactly.
you.
Teresa,
Sure
we
thing.
also have a question from Finley. They're saying, I'm wondering what makes short division seem easier. I personally really like it, but it seems like it puts a greater demand on working memory to subtract in your head versus writing it down. So it might not work for some kids.
Let me answer that question.
Sure thing.
And the problem that you have, the 43 minus 36, I don't want them to actually subtract, but go up instead. So start at 36, go up to 40, and then to 43. So by subtracting that way, it's much easier. Does that make sense?
Yeah, that's a great point. That
And
going up when subtracting is far easier than actually thinking in reverse.
And that example that she showed actually has the greatest possible remainders, 80 minus 9. So the 72, how far is 72 from 80? You know it's 8. Don't think 80 minus 72. That's too hard on the brain.
Mm-hmm.
Finley agrees that they say that this is the way I teach dyslexic children to subtract, add up.
Yeah.
As a quick side note, it's kind of funny because I've never been diagnosed as dyslexic, but I definitely have the traits. And I don't like to do subtraction any other way other than to go up. So it's kind of funny. I've never put that together, Finley. So thank you. I appreciate the little personal insight here. Michelle, did you have something?
No,
okay.
I'm just thinking, sorry.
Okay. Jeanette has an interesting comment. She says the book, it sounds like a philosophical look at why the curriculum is taught, how it's taught. I'd also say that the book also gives us the journey from what did we used to do in the 1400s, in the 1600s, how long division was not considered something that it was considered something only college kids did. And now we've got that down in the elementary. So there's a journey. And the other thing I really like about it, and Rachel didn't have an opportunity to talk about this with her addition subtraction, but and Dr. Cotter, you would know the answer to this. How many different ways there are to subtract, like 4-digit numbers? It's something ridiculous, like what, 13, 11, Dr. Cotter?
I think it's 7, but the 13 you're thinking of, the ways of subtracting 2 different fractions that are, well, you're going to be talking about that next time, that I've come up with. I think it's 12 or 13 different ways to subtract fractions. Yes.
And actually, I'll give you guys a quick note on that. I'm not going to be discussing that in my presentation, so you're going to have to get the book, but it's in there.
All right, great. Well, it doesn't look like there's any more questions. If there are, go ahead and speak up now.
Yes, I have one more.
Okay.
I say that children with learning disabilities of any sort should not be expected to ever learn long division. If you are working for my company, you better not spend company time doing long division. You better know how to use your calculator and what to do with that remainder. But learning long division, and it is not true that it's needed for advanced math. There was one mathematician said, oh, he needed it because you're dividing a polynomial by a polynomial in Fourier analysis. When you divide a polynomial by a polynomial, you never have that problem of guessing what number you want to go into it. That's the worst part. And Fourier analysis, yeah, who takes that? 1 of 1,000 people. I did take that course, and I don't ever remember any division in it anyhow. So I think that guy is totally wrong. So don't bother wasting the children's time teaching long division. Short division, yes.
Yeah, with kids with learning difficulties, bandwidth is so short. They have to use their brain on so many really important things that we can definitely peel off the lesser, the less important items, and long division would be one of those to boot out the door.
Actually, the NCTM, the National Council of Teachers of Mathematics, wanted to eliminate long division, but people clamored and they wanted it back.
Oh, that's interesting.
Yes.
Yeah.
Jenny's asking, I'd love to know what other things to boot out the door. What else should we kick to the curb?
Counting. Counting would be one. Flashcards, timed tests. Yeah.
Oh,
Michelle?
writing, a lot of extra writing. There was an era during the new math era, like even division. I mean, it took about a whole page to do division because you had to write all kinds of stuff on the side. Yes, get rid of that.
So
Michelle
what
asked a
is,
question.
I thought we were doing long division. That wasn't a long division problem? I guess I'm confused as to what is short and long division.
Right. So that's short division. You use that with where the divisor is just a single digit, right? You can use it for, this is called double short division, and I did not cover it. It is in the book, and it's also in the curriculum. You can use it for two-digit divisors, which have factors. So for example, let's see, if you were dividing by 12, you could break that up and divide by 3 and 4 or 2 and 6, right? So you would do it in separate steps. But long division is where you have you're writing down what you're subtracting underneath the dividend, and then you subtract, and then you bring down, and you're multiplying.
Yeah, yeah.
Let's do
Yara,
this here.
I mean, Kathleen
It's writing all the junk underneath.
Right. So if I have 360 divided by, I don't know, let's just do 4 because that's easy. So let's not make it 4. Let's make this 800. There we go. So 4 goes into 8. If I was doing short division, I would say goes in there 2 times, nothing left over. 4 goes into 6 1 time with 2 left over. 4 goes into 20 5 times. There's my answer.
Yep.
If I'm doing it long division, give me a second, I'm going to change colors. If I'm going into long division, I'm going to do 4 goes into 8 2 times. So I subtract that, and that's 0. And then I have to carry this guy down, and hopefully I get it going the right direction. So 4 goes into 6, well, 1 time. So that's 4. And then I have to do the 2, and then, oh gosh, I'm running out of space. And things get all messy and drizzly and weird. Whereas here, when you do it the short division, it's just super easy.
Mm-hmm. It's
So-
neat and compact.
Gotcha. So it's just the process, basically.
Mm-hmm.
Right.
Yeah.
Now, would you do short division with a number like, I mean, personally, if you're going to do 860 divided by 124, any normal person's going to grab their calculator.
Right.
But let's just say I'm locked in a cave and I have to figure out mathematically how to move the big old rock that's blocking my path. Well, you've also got a lot of time on your hands, so you can figure it out. But normal people, if they're facing this, they're not going to do it long division. They're going to use a calculator.
Well, actually, even the curriculum that do require long division, it's never more than a 2-digit number, which I think was interesting. Because back in the days when I was in school, it was a lot more than 2 digits because there were no calculators.
Okay. Anyone else?
We do
This
have
is a great conversation.
somebody from the Devane family says, my public school brain only functions with long division. I'm glad now to be introduced to short division. And somebody else put a nice little heart underneath there. So
Awesome.
But I think that's all the questions we have.
Okay, great. So thank you all for joining me. That was really fun. I love the discussion at the end, especially. So thank you for joining us, and I hope you all have a great day. Bye-bye.